Kia ora, here's question 3E from this year's integration paper. Thanks again to NCEA Memes. I've chucked a couple of them in here. If you don't want them in here, please let me know and I will redo the video. Right, so this one is the one about Murray. Murray is planning to hang a piece of art on a wall. The art is shown in the diagram below. Okay, so here we are. We've got the artwork and we've got the equation of the curved edge of the piece of art is f of x is equal to blah, blah, blah. Right. Murray has researched a way to make the picture balance by using the following formula to find the x value of the hanging position. So this is what we've got to work out here. It's one of those excellence questions where it's extremely clear what you have to do. Okay, so there are two integrations, one in the numerator, one in the denominator, and we just have to get on with it because we have to use that formula to find the x value of the hanging point. It's pretty hard for me to imagine that anyone's going to get the top number and the bottom number and not be able to divide one by the other, but let's see if I manage to muck it up. And also just looking at the picture, we know that our answer needs to be somewhere between 0 and 3, and just from looking kind of at like the shape of the artwork, you can see that probably we'd expect our answer to be like somewhere around here, right? So it's kind of like the idea of the center of mass. Right, so let's get going. Here are the memes. Well done to whoever made those up. They were very funny. There was one about Murray that I thought probably wasn't suitable for putting into a teacher written video. You can go find that one. Okay, right, let's go. We've got f of x is a pretty simple function. It's 1/3 of x squared plus 3 to the power of 2. The first thing that we need to work out is the integral between 3 and 0 of x f of x. So it's going to be x on 3 times x squared plus 3 to the power of 2 dx. I'm going to chuck that constant out the front. And now let's have a look at what we've got. Right, because I'm doing this for people who've just sat the exam, who are completely in the zone with their integration revision, I'm going to go reasonably fast here. You can see that this is a straightforward backwards chain rule problem, right? Because we've got a function to the power of 2, and we've got an inside function, which is x squared, and the derivative of that inside function is 2x. And out here, we've got 2x times a constant sitting here. So we've got x sitting here. So I probably wouldn't do this one using substitution. I would just get on with it. But I have done it using substitution at the very end of this video, if you did it that way and you want to have a look. It's actually pretty quick doing substitution. So it's kind of up to you what you prefer. But for me, I looked at it, put the constant down, and then I left a big gap to get my coefficients right. And I said, well, it's going to be x squared plus 3 to the power of 3. When I differentiate that, I'm going to bring down the 3. So I need to undo that with a 1/3. I'm going to get 2x for my derivative of the inside function, and I just want x, so I need to times it by a half. But that's about all there was to it. And now we've just got to work it out. So we get 1/18 of, let's see, 3 squared plus 3, so 12 cubed minus 3 cubed. You can do that on your calculator. I did that by hand, which was extremely unnecessary. I'll just show you how I did it by hand. I did 3 cubed times 4 cubed over 3 squared times 2, which kind of felt like a year 9 extension question about factors and stuff. I know some of you will be groaning at me doing this, but I just thought this was more fun. So there you go. So I get 3 times, I've got 2 to the power of 5 left in here. So 3 times 32 minus 3 over 2, which gives me 94.5. And that's the numerator of the thing we've got to work out. Right, now quickly doing the next bit, which is just the integral of f of x. So it's going to be x squared plus 3 squared dx. Well, I decided the fastest way to do this one was just to expand it out because it's not too bad. So, and then the integration is at level 2 level. So it's going to be x to the power of 4 plus 6x squared, right, this times 2, plus 9 dx. Working that through gives me 1/3 of 1/5 x to the power of 5 plus 6/3 of x cubed plus 9x between 3 and 0. Right, and of course 6 over 3 is just 2. So we'll magically change that to a 2. And when we evaluate that, we get 1/3 of 243 over 5 plus 54 plus 27 minus 0 plus 0 plus 0, which is very nice. That gives me a final answer of 243 over 15 plus, I've got 81 over 3 plus 27, which gave me, what did I get here? 43.2. I think that was an exact value. I actually can't remember. So now we've got to do the very last bit of Murray's painting. Back up to here, we've got to figure out this. And so we'll call it, I don't know, what are we going to call it? Murray's x is equal to 94.5 over 43.2, which equals 2.1875. And when we go back and look at the painting and we just sort of see where that's sitting, let me get rid of some of the mess on here. Hang on. I'm guessing most of you have stopped watching by now, but for those of you still left, here's Murray's artwork. And that's just about here, right? So I don't know, maybe one of you wants to do like a 3D printing of it and let us all know if it actually does balance. So this is the X value here, and this is how he's going to hang it up. We haven't talked about the Y value, but let's not worry about that for today. All right, thanks for watching. Complex numbers coming up after lunch.